Okay, welcome everyone to today's lecture on the module 4 of the digital switching system. Okay, these are the topics that we will be discussing in this module. In the first part, we discuss about the different switches, time switches, space switches, and combination of this. Okay, where we form a time space time switches and space time space switches. Okay, and the grade of service of these switching systems, and also we talk about the synchronization network. Okay, in the second part of this module we'll be basically talking about the software architecture of the different building blocks of the digital switching system. We have already discussed the building blocks of the digital switching system in the earlier modules. Okay, the software architecture and which is present in the different level what we are going to discuss in this module. Along with that, the software classification, the call models, and the software linkages during the call model, and also the feature flow diagram. Okay, this is one of the easiest module, and it is very easy to score module. Okay, only thing you need to concentrating on the key points of the topics that we are going to discuss. Okay, let's see what's a space switch mean. A space switch is basically takes some m number of inputs and n number of and provides the n number of outputs, where each input to this phase switch is a PCM stream or PCM IV. You know, from the previous studies we know a particular PCM IV can be categorized into two types. One can have a 32 channel, another one can have a 24 channel. Okay, irrespective of the number of channel a particular PCM IV is carrying, each of this input to this space switch that we are seeing here is a PCM IV, which has the 32 channel or 24 channel. The space switch, what it does is that it's going to take a slot. Okay, if you take a 32 channel PCM IV, there are 32 slots. The space switch, what it does is that it's going to take a particular slot of an incoming PCM IV and transfer that slot into a different slot. Okay, a different slot in any one of the outgoing PCM IV. Remember, it's going to take one slot of any one of the incoming PCM IV and it's going to transfer to any other slot of the any one of the outgoing IV. In this case, the slot 3 of the first PCM IV or PCM channel is been transferred into the 17th slot of the outgoing nth channel. Similarly, the 17th slot of the incoming nth channel has been transferred into the third slot in the first outgoing channel. Okay, here the thing you need to remember is that here there is this transfer of these slots from one channel to the other channel is taking at a particular instant of time. There is no delay of time in the transfer of slots. Are you getting? Okay, the slots that being interchanged from one PCM IV to the another PCM IV is happening at that particular instant of time. Okay, only the change of slots are taking place. The slot that is supposed to be transmitted at that particular point of time will assume one of the slot content of any one of the PCM incoming PCM IV. Remember, the transfer of slot into a different slot at that particular instant of time is taking place. Okay, there is no difference in time over here. That's the major difference between time switching and space switching. Space switching, what happens at a particular instant of time, you take a slot of a particular PCM channel and transfer that one into a or interchange or switch that particular slot into a different slot in any one of the outgoing PCM IV. This is the basic principle operation behind the space switch. Okay, the same diagram has been elaborated over here, where you have some M incoming, okay, M incoming PCM IV and N outgoing PCM IVs. Okay, all the cross sections, okay, all the cross points are basically used are connected or activated using AND gate. As you can see, basically they are using AND gate, and we have some control logic present at the bottom, which controls at what instant of time these gates should be opened or closed. Okay, for example, if a particular instant of time, a particular slot coming at a channel 2 of the incoming PCM highway, if that were to transfer or that were to divert it to any one of the outgoing PCM highway, let's say in this case the the first outgoing PCM highway, if any one of the slot from incoming PCM highway were to be diverted or were to be switched, the control logic will activate. You're going to activate the AND gate, which is connecting the row 2 and the column 1. Okay, by activating this, whatever the data that is being present at that point of time or that instant of time, which is coming into the number 2 PCM channel, will be diverted to the first outgoing PCM array. Similarly, if you are to connect a particular PCM slot, channel slot of a incoming highway to any one of the outgoing PCM highway, in this case, let's say I want to divert it to the second outgoing PCM highway, the only thing I need to do is to activate the particular AND gate, which interconnects the particular row and then column. This control of opening and closing of these gates are controlled by the control logic or connection store, which are present here. They are who is responsible for, which is already programmed. Okay, the decoding logic interprets the content of the connection store, and that in turn will operate the gates in order to open or close a particular gate. Okay, so this is how the phase switch works. When it comes to the time switching, well, let's say I have one incoming PCM highway and one outgoing PCM highway. Remember, we are not considering some m number of PCM highway, some n number of outgoing PCM highway. We only considering one PCM highway. It could be of 32 channel or it could be of 24 channel. Okay, in the time switching, what happens is that if a particular time slot has to be transferred into a different time slot, okay, different time slot at different point of time. Say for example, if a particular time slot, in this case the time slot 4 is coming into the system, okay, if this were to be transferred into a time slot 6 in the outgoing PCM highway, okay, if this were to be transferred or this were to be switched or this were to be allocated to the 6th slot in the outgoing PCM highway, the incoming content is stored. Content is stored. Okay, when the turn of the 6th slot has to be transmitted in the outgoing PCM highway, the particular content corresponding to the 6th slot, okay, will be read. Okay, that content is nothing but the content of the incoming, the 4th slot of the PCM highway. Here there is a change in time. Say for example, if you consider that 32 time slots of a particular PCM channel, if you can recall or if you can imagine the diagram that we have discussed in the classes, okay, every time channel, every time slot, okay, within those PCM highway occupy different points of time. Remember, every time slot in the PCM occupy different points of time. Say for example, I am receiving some PCM channel at the switch, and at the same time I am transmitting some PCM channel at the output end. Okay, if I am the controller or I am the switch operator, okay, if I want to transfer the present time slot 4 to the time slot 6, which comes later in point of time after the time slot 4, okay, so to transfer the time slot 4 into the time slot 6, you need to be waiting till the instant of time where the transfer of the time slot 6 occur. Okay, remember, the time slot 6 occur later to the time slot 4. Here, the whatever the incoming time slot of the PCM highway into the switch is stored. Okay, as you can see, there are some location, okay, some memory locations associated with the outgoing highway. In this memory location is nothing but a buffer, a particular content which is supposed to be transferred or stored. Say for example, each memory location represents the slot or the content of the outgoing slot to be, okay, transmitted. For example, if I want to transmit, okay, the time slot 1 content, I'm going to read the content of the, okay, address location 1 in the buffer, okay, number 1. I'm going to read it and I'm going to transmit in an instant of time where it's going to occupy only the duration of a particular time slot. Okay, if I want to transmit, okay, the second time slot, I'm going to read the content of the, okay, second buffer or second location in the buffer. I'm going to transmit the same as a particular time slot. Similarly, in time switching, what happens, to time switch a particular slot, you're going to read that particular slot, okay, and then you're going to store it in a time slot in which you want to transmit that particular time slot has been read. Okay, I want to transfer or I want to transmit time slot 4 of the incoming PCM highway at the time slot 6 of the outgoing PCM highway. What I do to perform the time switching operation, I am going to take the content on the time slot 4, I am going to store it in address location 6. Whenever the turn of the buffer to be read out, the sixth location comes, is going to read the content of this sixth location, which corresponds to the sixth slot of the outgoing PCM highway. Here the thing is that there is a storage of the time slot is being occurred, because the time slot 4, okay, comes before time slot 6. Okay, to transfer the time slot 4 at the time slot 6, it needs to be, stored till time slot 5 occurs, then the time slot 6 going to occur. At that point of time, the time slot 4 has to be transmitted at the time slot 6. Remember, here you are only having one PCM highway, one outgoing PCM highway. Here the transfer of slots are occurring, but at different point of time. Okay, at particular frame, if you want to transfer the particular time slot into different time slot which occurring at different point of time, you're going to use the time switching. Okay, here how the time slots should be recorded in which location of the buffer is controlled by the connection store. Okay, the logic which controls the switching operation of the buffer is done by a control logic called as the connection store. Okay, this is all about the time switching. Okay, so this is another same diagram which has been given in the book. Okay, we have two read operation which is going on. At the input, you're going to read the, read the incoming PCM highway. Okay, and you're going to store and you're going to interpret that particular, buffer according to the decoding logic which is going to store, okay, as you can see, this is the input what they are saying. The input is coming into this buffer and it will be stored in a corresponding outgoing slot, and it will be read accordingly. Based on the decoding logic. The same diagram has been represented in a simplified form. This is the diagram available in the book, and this is quite more elaborated explanation than this one. Okay, this is the same thing. This is the control store, connection store, and this is the buffer. Whatever the incoming PCM highway will be ready into a particular time slot at which you want to transmit in the buffer. Okay, the control logic will interpret what is the particular slot should be, particular content of incoming highway should be stored in which slot of the buffer. It's controlled using the connection store and with the decoding logic. Okay, okay, and the next we are going to see a combination of these time and space switches. Okay, there are two types. The first type is the space-time space switching. Okay, it's as you can see, it's a three-stage switching network. At the input, at the first primary stage, you have a space switch. They are referred as the A switch, which has the M incoming connection and K outgoing connections. Okay, remember, it is a space switch. Each connection has a dedicated PCM highway. As we have discussed in the space switching, if you have multiple number of input, multiple number of outputs, okay, each as a incoming PCM highway, and in between every connection which connects the switch A with the switch C, which is also a space switch, as a time switch. Remember, a time switch okay, is a single input, single output switch. For every connection, for every K connection which is connected to every K input connection of the C switch, okay, should have a intermediate time switch which has a one input and one output. The space switch equivalent of this can be interpreted as a n times m, n times n dimension switch. We already discussed about the multi-stage network in the module 3. Okay, we are also going to see the three-stage network equivalent of this STS switches. Okay, this STS switches operation is simple. Okay, whatever the m number of incoming highway which is coming into the system will be, okay, space switched at the A switch. Okay, if it is necessary, if the time slot needs to be interchanged of a particular outgoing PCM slot, okay, will be done at the time switch. Okay, which is nothing but a switch which is equivalent of n cross n dimension. This is the interpretation that we are seeing here. And at the same time, the PCM highway, the single PCM highway coming to the C switch can be space switched to any one of the M outgoing highways using the C switch, which is again a space switch. Okay, similarly there is another version, okay, of this which is referred as the time switch, which is called as the TST switch. Okay, instead of the time space switch at the input, we have a individual time switch for each connection. We have a individual time switch for each M incoming PCM highway, where at the initial stage the time switching or interchange of slots or transfer of one slot to the other slot, okay, which occurs at a different point of time, might occur in the time switch, which happens at every input, if there are m input, you have time switch for m input, and these m connections are given to a m cross m B switch, which is a space switch which can perform the space switching operation on these m inputs. Okay, after the space switching of these m inputs, okay, a corresponding output will be generated, and that will be given to again a time switch at the output end, where each m outgoing, okay, connection of this B switch has, okay, individual time switch. Okay, the, as you can see, it has the dimension of n cross n. If you are to write a switch equivalent of the time switch, the dimension can be represented using n cross n. Okay, n cross n. This is the operation of STS and TST switches. Once the time switch and space switch operations are known, it's very easy to explain the operation of the space time space switching and then time space time switching. The only difference is that at the for space time space switching, you have m incoming and k outgoing PCM highways, and the space switching occurs at the A switch. Each individual outgoing PCM highway has a time switch, and similarly at the C switch you have k incoming high PCM highways and m outgoing PCM highways. Again the time space switching occurs at the C switch. Okay, similarly in time space time switch, which is another combination of the time and space switching, okay, where the m incoming incoming PCM highways have individual time switches which are connected to m inputs of the B switch. After performing the space switching in the B switch, okay, the same output will be fed into the m outgoing PCM highways, where each individual PCM highway has a time switch at the output. Okay, this is about the space switch, space time space switching and the time space time switching. Okay, next we'll see the grade of service, of the STS network. Okay, so there are basically two modes to which we'll be finding the grade of service. There are two modes. The mode one refers to connection required to a particular free channel on a selected outgoing highway. Say in mode 1, what it says is that if you consider a space time space switch, okay, if I want to make a connection of a particular slot or particular channel of a particular PCM highway, okay, I need to be selecting a particular outgoing highway. Here, a particular channel is being mapped onto a already selected outgoing highway. Okay, it's not like you don't select some random any free outgoing highway to switch the incoming PCM channel. Okay, in this case, the connection is required to a particular free channel on a selected outgoing highway. You already selected a particular slot to which you want to transfer the or switch the incoming PCM channel. Okay, okay. The grade of service of such a mode for STS network is given by B1 is equal to 1 minus B whole squared, this whole term to the power of k. Okay, where B represents, okay, small b, not the big B, the capital B1 is the representation of the B1 is the representation of the grade of service of the STS network. Small b represents the number of switches. In this case, you have number of time switches, right? Or the number of links which connects switch A and then switch C. Okay, the small b represent the number of the small b is the blocking probability. Sorry, where small k represents the number of intermediate links or switches. The small b represents the blocking probability of these intermediate links or switches. Okay, so if you take STS switch, you can find number of time switches which connects, which is present at the intermediate state between switch A and then switch C. Okay, where the k represents, okay, where the k represents that many number of links or switches, okay, present at the you know present at the particular STS network, where small b represents the occupancy of a link, that is occupancy of these intermediate links, okay, are 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 presented using a notation called small b, which is given by x over y, where small x represent the total traffic offered in busy hour, where y represent the number of PCM channel, which is the product of number of PCM channel times the number of links. Okay, remember, okay, small b represent the occupancy time of these links, these intermediate links. Occupancy time of this intermediate links is given by small b, okay, which is given by small x over small y, where x is nothing but the total traffic offered in the busy hour, and y is equal to number of PCM, which is the product of number of PCM channel of a particular incoming PCM highway times the number of links, okay, which is present in the, okay, STS network. Okay, so we'll see the grade of service of the STS switch, okay, for mode 2 connection. Okay, what is mode 2? In this in mode 2, the connection is required to a particular outgoing highway, but any free channel on it may be used. In mode 2, it's not like a particular uh, particular outgoing free channel must be selected to connect the incoming PCM channel. It's not like that in the mode 2. In this case, any free channel can be selected for any particular outgoing PCM highway. Okay, or any PCM outgoing channel or any PCM highway can be connected to any free channel available. There is no restriction on a particular PCM highway must be selected in order to make the connection. Okay, in order to make the connection. Here the grid of service for mode 2 for STS switches is not given by a notation B2, which is given by B1 plus 1 minus B1 times C whole to the power of small n, where capital B1 represents the grade of service of STS switches, okay, that we have already discussed. Once this is derived, okay, using the numerical value of B1, we can easily derive the grade of service of B2, where this C represents the probability of the blocking probability. Okay, I've written only probability. The blocking probability of a outgoing trunk. Blocking probability of an outgoing trunk in a busy hour is given by C, capital C, and small n represents the number of channel of a particular incoming PCM highway, where small n represents the number of channel of a particular PCM highway. Okay, you can use a 32 channel system or 24 channel system based on that. Okay, based on that, you can decide the value of n. All of you, you can start putting your USN in the chat box. You can start putting your USN in the chat box. Yes, Sana?
Sir, what is the difference between STS and TSTS, sir?
It is the combination, like there is in practice what happens. Okay, in some stages you need to transfer the time slots, okay, in terms of time or in terms of spaces. Practically, these two are the systems which is being implemented in the real world. Okay. Okay, you're muted, I guess. It's muted, Sana. Fine. If you have studied already the PCM system that we have already discussed, I don't think you'll find it difficult to understand this one. Okay. We'll go back to okay. If you can see, okay, of mode to connection, this is the equation. Okay, B2 is given by B1 plus 1 minus B1 times C all to the power of small n, where C represents the blocking probability of an outgoing trunk. Okay, probability of outgoing trunk to be busy, which is nothing but a blocking probability of an outgoing trunk, which is given by total traffic offered in a busy hour. Okay, where Y represents the product of number of PCM channel times the M incoming or outgoing PCM channel. We'll see how to substitute these values, okay, these values, okay, when we see the problem on this. Okay, this is a space switch equivalent of STS system. Okay, we already discussed about STS switch, right? We can interpret that switch as a three-stage switch where okay, the three-stage switching we already discussed about it. The three-stage switching, the space switch can be represented as a space switch of M cross K switch at the input end, okay, which is having M inputs at each side as a input, and the number of links which connects, the K number of links which connects these two space switches can be interpreted as N cross N switch, where it has one input and one output. Similarly, the space switch at the output end has K cross M dimension with K inputs and M outputs. Okay, this is the space switch equivalent of the STS switch. If in questions in the examination, if they ask you to write the space switch equivalent of the STS switch, this is what you are supposed to write. Okay, let's look at some of the problems discussed on the GOS, grade of service of the STS switch. Okay, it says okay, STS network has 16 incoming and 16 outgoing PCM highways. Okay, the number of PCM highways in this case are 16. Each is conveying 24 channel. Each 16 channel, okay, each 16 PCM highways coming into the system, okay, is a 24 channel system. Okay, between the incoming and outgoing space switch there are 20 links. That means the intermediate links which connects these two space switches, as it is a STS switch, the number of time switches or the number of links that you are using to connect these two space switches are 20. Okay, during the busy hour, Okay, then the network offer 300 elongs of traffic during the busy hour. This particular network offer 3 elongs of traffic, and it can be assumed that this is evenly distributed over the outgoing channel. Okay, estimate the required grade of service. Okay, in this case, is asking you to find the grade of service under mode 1 and mode 2. You already know the equation for mode 1 and mode 2 grade of service of the STS switches. Okay, only you need to get to know about the parameters to substitute into this and find the grade of service of STS network. Okay, where the number of incoming and outgoing PCM highways are same. That's why the number of incoming and outgoing highways in this case M, it's 16. Okay, the number of time slots of a particular PCM highway is 24, and the number of links which connects or number of times which connects these space switches are 20, where 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 the traffic offered during the peak hour is 300 long. The traffic offered peak hour is 300 long. Okay, we have assumed this no equation. The grade of service of B1, okay, is given by 1 minus small b to the whole square to the power of small k. Okay, where b is unknown, which is not given, which is the occupancy of a link, the intermediate links, the probability of blocking of intermediate links, which is given by the total traffic offered in busy hour over the number of PCM channel times the number of links. Okay, okay, the total traffic offered during the busy hour is 300, which is given. Okay, the number of PCM channel, the number of PCM slots per PCM incoming highway is 24. It's a 24 channel system. The number of PCM channel in this case is 20, and number of links, the intermediate links in this case, which is small k, is 20. Okay, well, in that case, okay, the probability of blockage of these intermediate links become 0.625 long, 0.625 long. Okay, well, B1 can be calculated by substituting the small b value to the whole small b value in the B1 equation to the power of 20. Okay, which results in 0.0482. Okay, which is a dimensionless quantity, which is a grade of service and which is a dimensionless quantity. You already know the equation for STS switch. The grade of service for the grade of service for mode 1 is given by this equation. We are using the same equation over here, where we have found out the small b to be 0.625 long, 0.625 long, which is the blocking probability, which is given by the total traffic offered divided by number of PCM channel in a particular PCM highway times the number of intermediate links, where which is given by k is equal to 20. 20 is number of intermediate links, number of slots is 24, which gives the small b. The same thing has been substituted and the result is this. Similarly, for grade of service of the mode 2 is same thing has been whatever the equation that we have discussed has been used over here. Please, we'll continue with this. Okay, as I have only 1 minute left. Okay, we'll continue with this. Okay, in the 12 o'clock session. Please, all of you remember to join back at 12 o'clock session.